Good morning, everybody. My name is Damien Burks, and I'm here with Rudra Gupta, and today we're going to be talking about, or the title of our talk is called Come and See CCC and CFI. In this presentation, we're really going to just talk about some of the value adds of CCC, why we started and founded both of the projects CCC and CFI. But before we get into all of that, let's just go over some of the pros and cons of the public cloud. So we all know for a fact that the public cloud, number one, is being adopted at a rapid pace by most of the financial services institutions. And it comes with several different benefits, right? You got scalability, you got cost effectiveness when configured correctly, you have innovation with all the generative AI tooling and whatnot, global availability, and also disaster recovery and resilience. But that's not the reason why we are here to talk to y'all. The reason that we're here to talk to y'all is to explain and emphasize the challenges and risks of the public cloud. So some of the challenges that we face with the public cloud when it comes to FSIs is that, number one, governance and compliance is definitely one of the challenges, right? And that ultimately it's very hard to navigate the regulatory landscapes of those of things within the public cloud, simply because you're deploying things in so many different regions to adhere to that. There's also a skill shortage within the public cloud, right? It's hard to have or find someone who's multi-cloud certified, right? And also the shared responsibility model looks very different for other different CSPs, and that's something that we need to really kind of discuss and figure it out, right? So with those challenges, we create these risks. And some of the risks of public cloud has been noted, based on research from different FSIs and stuff like that. Data breaches is like one of the most critical risks within the public cloud, and it can really have a devastating impact and consequences for organizations, especially when your data has been compromised and then shared on the dark web or whatever. Second thing, and I'm just going to kind of put these two together, legal and compliance and country-specific risks are definitely a problem. Legal and compliance, the compliance that we have, or different countries have various regulations that they have to adhere to, right? So when you fail to comply to those regulations, it opens up that door for hurting your reputation, and you face various different penalties, financial and legal, and so many different other things. But with the country-specific risks, let's say if we're deploying something into Europe, right, and we have data stored in an S3 bucket somewhere in Europe, you have to adhere to GDPR practices and all of the different compliance regulations that they have there for data protection purposes. Versus in the US, you still have to adhere to HIPAA and CCPA and all the other different regulations. And then last but not least, let's talk about supply chain. So supply chain, number one, poses a great risk, especially when you're deploying things into the cloud, because if something that you deploy is vulnerable and you deploy it into your account or project or whatever, it gets breached. That's a pivot point for the attacker to go and reach into every other thing. So that's one of the other risks that are associated with public cloud that we're actually going to talk a little bit more about how we solve it. So I mentioned the challenges, I mentioned the risks, but how did we solve this problem, right? So we can solve this problem by effectively creating a security standard that FSIs can adhere to, that is basically commonly shared amongst, that's common, right? Creating those controls and whatnot across all the various different CSPs. Why is this important? Well, there's two key reasons why we believe this is important. Number one, it simplifies those regulatory issues that most of us find FSIs really need, right? That differ based on each of the various different CSPs. And on top of that, the regulators themselves are looking for a nice way to establish and enforce those technical standards to reduce the risks that come about with the public cloud. So what have we, and as a representative of Citi, also FINOS, have done about it? Well, we founded CCC, Common Cloud Controls, and CFI, Compliant Financial Infrastructure. So let's talk a little bit about CCC and what it does. So CCC is basically an open standard project that describes consistent controls for compliant public cloud deployments in the financial services sector. Essentially, in layman's terms, this project is basically a collaborative project that pretty much aims to develop a unified set of common cloud security controls, threats, and feature catalogs with the necessary mappings to the various different regulations and whatnot, or not regulations, but we're going to say like well-known frameworks that FSIs can contribute to that are common across major CSPs, right? So CCC, there are several different benefits that CCC gives to the end user. The first one is that we define the best practices around cybersecurity, cloud security. So by doing this, we basically aim to standardize those security controls for the banking sector, and that we do that by providing that common set of controls that meet the needs of FSI firms. And in a sense, it's basically going to be, while we allow all the FSI firms to come and collaborate with the project, we get that insight from the various different FSI firms when they, whatever it is that they're actually facing. We define those practices. Not only that, but with those catalogs that we're creating, we have one target for the CSPs to conform to, right? And the thing is that with these controls and these catalogs that we're creating, we can communicate that to the CSPs, and it eliminates the overhead of having to actually adhere to all these various different standards that have been, brought onto us. In addition to that, we're all sharing the common burden, sharing the burden of a common definition. So we reduce that compliance overhead with those, very abstract, generic, yet impactful catalogs that we have created that can be adopted by the FSIs that trust the catalogs that have been created by a community of us. A common path towards implementation. Ultimately, what we're basically doing is we'll be collaborating with our sister project, CFI, who is basically going to be creating the validators and various different processes for creating secure ISC methods for deploying and validating the infrastructure that has been deployed. And lastly, a path towards certification. So soon, we will offer a path towards certifying the methods that have been deployed, as well as some of the catalogs with the CSPs, if they adhere to what it is that we have built. So these are the 5 key requests that someone like me, who develops controls and custom controls within our environment and ensures that we're actually compliant and securing our infrastructure within a public cloud. For me to be able to use CCC, or for me to have something generic that is kind of common, especially if I'm developing something AWS, Azure, GCP, I need something that's very common across all of these. The first thing that I would need is a common list of features, and we want to be able to have that taxonomy of those lists of features that's common across various different services for all the CSPs, right? The second thing that I would need is the actual controls and the threats that corresponds to those features for each of those services to help me build the controls in a rapid form, in an accelerated pace, without compromising on the speed of delivery while staying compliant. The third thing is that once we've kind of gotten those controls, then I need a way for us to be able to review and compile those controls for release, right? So that every time we make a change or change to the process, to the control, to the threats catalogs, we need something that is automated that we can release to the public, right? Once we got the delivery taken care of, then I need a communication aspect of it, right? I need some way or a method or a team that can coordinate and communicate to the wider community what has happened and what controls have been created, what catalogs have been created, to keep us updated. And last but not least, once we got all of that taken care of, I need a way to implement it. I need to understand how can we embed this into our processes. And that's where CFI comes into play. So I gave you the 5 key requests or needs. Now let's talk a little bit about the controls development lifecycle, because this is ultimately how we do things within CCC. So at the very first stage of the lifecycle, it starts with the taxonomy working group. And I'm going to get more into what the working group's jobs are in a second. But ultimately, the taxonomy working group, what they will do is that they will identify a common cloud service category, right, amongst all the various CSPs. So we know that every CSP has storage of some type. We know that for a fact. And then what's going to happen is that they're going to create a list of minimum viable features for each of those services. So we have storage, then we'll have object, right? And then from there, what they'll do is that they'll specify the testing requirements for the features inside of a Gherkin file, right? And this could change, of course. But if you look to the right of the screen, or maybe to your left, yeah, to my left, you'll see that there's a YAML file that basically specifies like all the various different features. So that's how we develop our catalogs, is in YAML. Once the features have been specified and created by the taxonomy working group, then we pass that information or that information and that catalog onto the security working group. So then the security working group will create the threats and control catalogs based on the features or with mappings to them, as well as they'll include those mappings to some of those well-known frameworks like ISO, you have MITRE, ATT&CK, you have CCM, so on and so forth. And then what they'll do is that they'll also update that same file by specifying the testing requirements for the controls. Once that takes place, right, then they'll move on and they'll pass that information on to the delivery working group. And the delivery working group will then take that information and compile the list of artifacts and prep them for an initial release candidate using automation. So we are using an artifact compiler that has been written in Golang, and we publish all of our artifacts. We take the YAML and the Markdown. We generate those omnibus controls and catalogs in the machine readable form and also human readable form. And then we'll take that information and we'll publish it using GitHub releases, and you'll have the links to all the artifacts there. And once we've taken and we've done that, then we'll coordinate with the communications working group about the upcoming release so that we can notify the individuals. And that's where, once those artifacts have been versioned, compiled, and released, we'll notify that communications working group, as I just said, and then what they'll do is they'll just communicate that to our stakeholders about what has been released, such as CFI, for example, and then they'll also help create and maintain those feedback loops with the wider community so we can learn what we're doing right and also what we're doing wrong. And with that, these are a list of all the various different working groups that we have within CCC. The ones that are in bold are the ones that are instrumental to our controls development lifecycle, but duplication reduction and community structure are the two that really kind of keep us in check. Duplication reduction focuses on ensuring that our standard doesn't duplicate any existing standards, so we're unique in that regard. And the community structure working group is really ensuring that we adhere to the governance and structure of our CCC project. Now, with that being stated, I'll go ahead and I'll pass the mic over to Rudra, and he's going to talk about CFI.
Thanks, Damien. Hope you guys are having a great conference so far. CFI, or Compliant Financial Infrastructure, exists to accelerate the development of controls given to us by CCC. In the past, CFI was responsible for defining and developing the controls, but since the formation of CCC, our focus has just been on the development side. As part of CFI's objectives, the project provides CI/CD friendly compliance validation plugins. This way you can test your ICs modules against the controls written by CCC for compliance. Or you can just use our ready-to-use IC modules and deploy it within your infrastructure. So as you're developing your ISEs, and with the help of deliverables from CCC and CFI, you can get real-time compliance. So with the help of validators, you can check in real time if your implementation causes compliance drift as you're developing your ISEs. This way, you're getting continuous compliance feedback, and if there is a drift, you would know why. You can get multi-cloud compliance. So if you're deploying your infrastructure across multiple cloud providers, then our cloud-specific validators and ISEs can help make sure certain compliance standards are being met, therefore ensuring consistent security and compliance across different cloud environments. Sorry. How do I scroll? Sorry. You can also get reduced time to compliance. I understand compliance is one of the most time-consuming and costly aspects of infrastructure deployments. So with the help of the validators and ISEs produced by CFI, you can reduce the time it takes to produce compliant infrastructure. You can also get organized, structured, and versioned ICs, and in the future, certified ICs as well. So over the next couple of slides, I'm going to talk about the development process of the control itself and demo how a control can be validated once it's released by CFI. The control that you're seeing on screen is related to object storage, which is a service by Google Cloud. Obviously, there will be many more controls defined to achieve compliance for this service, but for the purposes of validation demo, I just picked out one single control from the specification. One thing to note about a control is in order for it to pass, it must satisfy all the test requirements. This control is about checking if or preventing access to the buckets or the objects within the buckets if you have untrusted KMS keys. And the test requirement here says that if my organization policies does not allow the access to the bucket with untrusted KMS keys, then I shouldn't be allowed to access the bucket. So now that we have our objective clear, we can talk a bit about the development process of the control itself. The development is done in 4 steps. First, you have to install our test harness privateer. Privateer can be installed in 3 different ways. You can build it from the source, you can use our installer bash script, or you can download you can download the binary from one of its stable releases. Once privateer is installed, you can generate the code base from the validators or for the validators directly from the input given to us by CCC. This does 2 things. Number one, it reduces the amount of time for developers to start writing the controls. And number 2, like as an engineer, the step I really like is the amount of information it adds to the code base, especially like the function name. So while I'm developing the validators and the functions, I exactly know what I'm writing about. Then once you have the code base created, you can start working on defining the actual validators, writing the actual functions and the test requirements. And then once your validators are written, you can then execute it against privateer, which is our test harness. So now let's see a demo of this step in a local environment, as it may resemble what may happen in your CI/CD pipeline. So yeah, it's demo time. This is the demo of how a validator can be executed against a test harness in a CI/CD environment or pipeline. The sample function that you are seeing on the screen is the implementation of the control that we were talking about before. We will convert our implementation into a binary and then execute it against our test harness, which is privateer. Privateer is going to run each of the test requirement one by one, and it will only move to the next one if the previous one passes. The test harness will then return the output of the checks it performed against the deployed infrastructure in 2 separate ways. Number one, it's going to return an initial response in the CLI itself, and then it will also generate a detailed output in the local directory. In this case, the bucket we were checking our control against didn't have the right policies or didn't have encryption in place. So the output here that we're expecting is our controls and the test requirements didn't pass. So let's look at the output in detail. It's right here, sorry. So this is the output returned by privateer. You can use this response to determine if any further action is needed on your end or not. As you can see, with our test harness and with the help of validators, you can check if your deployed infrastructure complies with the standards set by CCC. And with that, I'm going to invite back Damien again to explain why does this matter again. Thank you.
All right, so y'all seen everything. So let me reiterate to y'all why this all matters again, right? So number one, there are way too many standards to adhere to just off the rip. And we know for a fact that with CCC, we add that value by consolidating that and making those controls and threats and feature catalogs, giving that to y'all with the standards, with mappings to those standards, so you don't necessarily have to adhere to them at a different separate level, right? We're consolidating it all so that you guys we're eliminating that overhead for y'all from a compliance standpoint. We also know that the enterprise definition, compliance definitions are way too complex. And that's something that we're here to do. We're here to simplify that by creating those catalogs, right? And lastly, but not least, where CFI really comes into play is that we know that the GRC teams really struggle to validate those policy compliance with those deployed resources. And that's where that validator comes in. And you can use that to be able to ensure that all the resources that you have deployed in your environment are in fact compliant based on the CCC control catalogs that have been created. So with that being stated, how do you get in touch with us? So number one, we are looking for people to come and contribute to our project. So please feel free to scan those QR codes, go to our GitHub projects. If you find a working group that you would like to contribute to from a CCC side, definitely come back and come over and speak to me after this presentation. As well as with CFI, if you're interested in building out those validators and also writing those secure IAC methods, come talk to Rudra. We can get y'all onboarded and we can start talking about that. And thank you guys so much for listening to our presentation and listen to me ramble a little bit. And that's it.